This is algebra 2, lesson 1.7, solving absolute value equations and inequalities. Two goals we have. One of them is to solve absolute value equations and inequalities. Second one is to use them in real life problems, which we'll look at the end. We get on page 50 in your textbook. First thing we have is a definition of the absolute value of a real number. Absolute value, remember, is a distance. Time you talk about the absolute value of something, you're talking about how far is it from the number 0. 3 is 3 units from 0. 1, 2, 3. Negative 3 is also 3 units from 0. 1, 2, 3. That's why absolute value can never be 0. I'm sorry, that's why absolute value can never be negative, because distance is never a negative number. If I take Chris's tape measure and measure it 10 feet and then throw it back to him and he measures it back to me, it's going to be the same 10 feet. It's not going to say negative 10 feet. That's why distance can't be negative. Solving an absolute value equation says the absolute value equation, the absolute value AX plus B is equal to C, where C is greater than 0. All C is greater than 0. This just means it's a positive number right there. Is equivalent to the compound statement AX plus B is equal to C, and AX plus B is equal to negative C. The reason being is because that absolute value, this right here, is talking about the distance. So it's talking about the distance from 0. So C would be here, and it would also be here. Since it's talking about the absolute value, it's going to give you two answers for it. Let's look at an example to make that make more sense. The absolute value of 4x plus 2 is equal to 6. You're going to write it as two different answers. 4x plus 2 equals 6, or 4x plus 2 equals negative 6. This is very easy for most people to comprehend. Anytime you have the absolute value, write it as two separate answers, 6 and negative 6. That doesn't just mean work the problem and then whatever answer you get at the end, say it's either positive or negative. It doesn't work that way. You have to set it up as equal to both positive and negative. So then just work them as two separate equations. This is a simple equation. Undo plus 2 on both sides by subtracting it, then divide by 4. Okay, right here we're just doing them at the same time. Subtract 2 on both sides. When you subtract it from 2, it gets 0. It cancels out. 6 minus 2 is 4. Negative 6 minus 2 is negative 8. Then divide by 4 on both sides. 4 divided by 4 is 1. Negative 8 divided by 4 is negative 2. So we have two answers. It's both 1 and negative 2, or 1 or negative 2. That would be the answer to both of that. Or you can say simply this: x is equal to 1 and negative 2. Both answers at the same time. Okay, on the back, everybody, there's a little area for you to work this problem here. The absolute value of 6x minus 3 is equal to 15. Take about 45 seconds on that one. Okay, again, anytime you have absolute value like this, 6x minus 3, you're going to make it two problems. 6x minus 3 is 15, just like it says, or 6x minus 3 is negative 15. So they work them the same way. It's the same steps. You add 3 to both sides. So you have 6x equals 18. Add 3 to both sides. 6x equals negative 12. Undo 6 times by dividing by 6 on both sides. 18 divided by 6 is 3. Divide by 6 on both sides here. X is negative, is equal to negative 2. So both answers, 3 and negative 2. So it's as simple as taking whatever's inside the absolute value sign and setting it equal to positive and negative. And as Algebra 2 goes on, we'll get much more advanced into this, but it's going to basically keep coming back to this same concept. Set it equal to positive and negative. The other thing we're looking at is absolute value transformations involving inequalities. When you're talking about not equal to C anymore, now for the first one it says less than C, again, where C is greater than 0, just means positive number, means that AX plus B is between negative C and C. It's still positive and negative, whatever that value is, but it's in between them. So the equivalent inequality is it's in between them. It's this, ignore this for a second, it's this is less than C, and that is greater than C if you read it the other direction. AX plus B is greater than negative C. Some students tend or prefer to write it anytime you have the absolute value of AX plus B is less than C. Some students prefer to write it this way. AX plus B is less than C, the positive value, and AX plus B is greater than negative C. They prefer to write it as two separate problems. It's going to work the exact same way. That's going to work the exact same way as writing it in the middle like this. The other one, that's less than. The other one, greater than, is talking about the numbers that are beyond that value. Anytime you have this one, again, this one was less than. This one right here is talking about greater than. When they're greater than, you're going to make an or statement. So the first one, less than, is an and statement. Write this on the side, everybody. Less than equals and. Greater than equals or. Or is the one that you write separate. And is the one that you write in the middle. And then that last portion simply says less than is the same thing as less than, equal to. Greater than is the same thing as greater than or equal to. And nobody has any issues with that. You don't change those. Okay, example number 2 says solve absolute value of AX plus B is less than C. Well, we said a minute ago that when we have less than, that's an and statement. That's the one that goes in the middle. So what we're going to say is 2x minus 3 is less than 3, and 2x minus 3 is greater than negative 3. So what we did is we just wrote that as an equivalent inequality. Again, if you ignore this side for a second, you see 2x minus 3 is less than 3. And then if you ignore the other side, this one, and you read it from right to left, 2x minus 3 is greater than negative 3. Again, sometimes it helps students to write it as two separate ones. So now you just have a simple compound inequality. I know that's kind of, that contradicts it, but it's a compound inequality. Undo minus 3 by adding 3 to both the left, the right, and the middle. It leaves you with 0 is less than 2x is less than 6, and then divide by 2 to both the left and the right along with the middle. 0 divided by anything is 0, cancels out in the middle. 6 divided by 2 is 3. So 0 is less than x is less than 3. So what this says right here is the solutions are all real numbers that are greater than 0 and less than 3. And you can see on this graph that it's talking about all of the numbers between 0 and 3. All of the numbers between 0 and 3. And anytime you have an inequality where your x is in the middle like this, you're going to graph an area that's in the middle of two different values. So that was one that was a less than inequality. Remember, less than means and. You write it as a compound inequality in the middle. Let's take a look at one by yourselves. Try this one on the back. 4x, the absolute value of 4x minus 9 is less than or equal to 21. This is an and inequality. Take about a minute on this one. If you're having difficulty with this one, it's probably because you're having problems setting it up, not necessarily solving it. So again, the absolute value of 4x minus 9 is less than or equal to 21. The first thing you're going to do is this. 4x minus 9 is less than or equal to 21. Okay, notice all I did was drop the absolute value symbols. But since this is less than, again, less than equals and, so it's going to go in the middle. So this is what I mean by reading it backwards. This 4x minus 9 is greater than or equal to, not 21, but we already got less than or equal to 21, not 21, but negative 21, just like the equations were a little while ago. And what I mean, since I read it as greater than, notice the big mouth is eating the big number being 4x minus 9 in this case. It's eating the larger side. So now we got something, now we have a compound inequality that looks like this. Now we just got a left, a middle, and a right, so we're going to undo each of those statements. Undo plus 9 by adding 9 here. I'm sorry, I said undo plus 9. I meant minus 9. Add it here and add it here. This is going to give you 30. Negative 21 plus 9, we got to subtract them. 11 minus 9 is going to be 2. And we had to borrow 1, so it'll be negative 12 is less than or equal to. This canceled out and left us with simply 4x. And that canceled out and gave us 30. We didn't reverse the symbols because all we did was added 9. Since we did that, we need to undo 4 times something by dividing by 4. We divided there, divided here, and divided here by the left, the right, and the middle. So negative 12 divided by 4 is negative 3. That canceled out, and just x is in the middle. 30 divided by 4, there's no number that goes into both of those, so we'll simply leave it as 30 over 4. It's not, you don't need to reduce it even though it's improper. Then you just have to ask yourself one more time, do I need to reverse the symbols or leave them alone? All we did was divided. This comes out to be negative, so don't let this confuse you. Just because that came out to be negative doesn't matter. We divided by positive numbers for all of them. And since we did, we're leaving our symbols just like they are. And this is your inequality. And this one says solving an inequality with greater than. The last one we did was and, because it was less than. This one's greater than, so it's going to be or. Greater than is or. Or inequalities usually are much simpler for most people because you just write it as one or you write it as the other one. You write them separate. So the absolute value of 2x plus 7 is greater than or equal to 3. So 2x plus 7 is less than or equal to negative 3. Notice we reverse the symbol. Less than or equal, and not positive 3, but negative 3. Or 2x plus 7 is greater than or equal to positive 3. Notice that one looks exactly like the problem, just without the inequality symbols. So that's both of them. You reverse the symbol, and you make it either positive or negative, whatever it was. So it was 3, you make it negative. You leave the symbol alone, you leave the number alone. So we got two of them separate. 2x plus 7 is greater than or equal to 3. 2x plus 7 is less than or equal to negative 3. Two separate problems. So undo plus 7 on both of them by subtracting it on both sides. Negative 3 minus 7 is negative 10. 3 minus 7 is negative 4. Undo 2 times x by dividing by 2 on both sides. X is less than or equal to negative 5. X is greater than or equal to negative 2. Again, notice we did not reverse the symbol here. Even though it became negative 5, we divided by positive 2. Even though it became negative 2 on the right, we divided by positive 2. No reason to reverse the symbol. And then this is just the description of what happened right here. The solutions are all real numbers less than or equal to negative 5 or greater than or equal to negative 2. And when you graph that, it'll look just like this. Less than or equal to negative 5, so it's saying negative 5 and everything to the left, or greater than or equal to negative 2. Negative 2, everything to the right. And let's take a look at one more example. This one on the back. Solve. The absolute value of 3x minus 2 is greater than 18. Take about 45 seconds on that one. Okay, this one is a greater than. Remember, greater than is or. Less than is and. Greater than is or. So we're going to take 3x minus 2 is less than 18. Notice all I did was remove the inequality symbols. Everything's written just like it is. Or 3x minus 2. Reverse the symbol instead of greater than, less than, and take 18 and make it negative 18. So then just solve the two inequalities. Undo plus 2 on both sides leaves you with 3x is greater than 20. Undo plus 2 on both sides, 3x is less than negative 16. Undo 3 times something by dividing by 3 on both sides. X 20 over 3, there's no number that goes into both of those. We divide by positive numbers, so we'll leave it, say, greater than 20 over 3. Divide these both on both of these by 3. X negative 16 divided by 3. Okay, right? Negative 16 over 3. There's no number that goes into both of those. And we divide it by a positive number again. So less than, leave it just alone. So x is greater than 20 over 3, or x is less than negative 16 over 3. And we'll cover the rest of it tomorrow.